So with both sides somewhat roughed in, and the whole system looking decent, you know, inside of a thou, I think I was side to side, end to end on the surface plate, checking the height of this here. I don't want to go, like I said, I've got very little room for error on this surface here in order to get the lead screws to line up in both X and Y directions. So I'm trying to sneak up on this, and so what I'm going to do now is I'm going to prepare to start using the saddle to check parallelism of the two ways here and how coplanar they are. And so I got working on how am I going to get the saddle to sit on here. You know, manhandling is not good. Especially when you're trying to blue and spot things, you're way better off to you're way better off to set parts down. So I got looking at the saddle, and I was going to build a bracket. And lo and behold, I have been using a different bracket for other purposes along the way here, and I bolted it on to the saddle. And back in the back corner, you probably can't see it here, I put one bolt in and I've got it clamped here. So what I'm going to do, and that was the first shot, I put that on there, tightened the bolt up, put the clamp on, picked it up with the hoist, and the thing's sitting, well, I guess I haven't put a level on it, but it looks really good. So all I'm going to do now is I'll flip it over and spot, put a new hole. So this bracket now will become useful, and for 3 different operations where, depending on what hole pattern you use, it'll work for 3 different lifting devices when restoring a Bridgeport. So sometimes you just get lucky. So I've been through 2 cycles with the straight edge on either side, and then I've just run the saddle from this side here, took it off, blued it again, and then did the second half. And again, I'm still really pleased with how coplanar the 2 sides appear to be at this point anyways. You can see, I think it's showing up there, you can see this hole in here. That's really low, and I picked that up. That's just wear, so we're trying to get down to that point there. Seems to be a little bit different pattern up at this end, with a little bit more on the inside closer to the dovetail. So I'm going to work away at kind of alternating back and forth between the saddle and the straight edge for a couple of cycles here, and then what I think I want to do is get it actually up on the surface plate with the saddle on here and start looking at geometry as it would sit on the machine, only upside down. So this is straight off of scraping the spotting that I got from the saddle, and this is the front side of the table, and now this is with the straight edge now following up after the saddle. So I'm excited about the results here. They're looking good. So I think I'm going to scrape this spotting here, and then, like I said, I want to put the table up on the surface plate, and then throw the saddle up on the table, and start checking geometry that way. With the saddle now on top of the table, on top of the surface plate, I get a little bit of way oil on the ways, and I'm just doing some initial quick checks of, with it traveling, what it looks like as far as how parallel the ways are. How parallel the ways are to the top of the table. And so with the GoPro set up here, I'm just going to sweep along here and show you what it looks like. With the scraping on the cast iron surface plate here, the needle bounces around a bit, but end to end looks like somewhere around 1.5 thou, which won't take much to get rid of. So that's looking good. And the next thing I'm going to do now is I'm just going to verify some heights from here to here, see what we've got. So this was the next thing I wanted to check here with the saddle up here on the table. So I'm back to my tense indicator, and a couple of comments out there, and normally I'm trying to use something flat and ground like this 1, 2, 3 block when I'm measuring for geometry and heights of things, because the surface finish of a scraped surface is hard to get an indication from. And then if I come over here, so that's within 1/10 there. And now what I'm going to do is I'm going to go to the opposite side and verify what it looks like going this way here. Which unfortunately, so I took the bracket that I used to lift the table off. That's why I couldn't get around to the back. And I've got the indicator now set up on the back side here. And a little bit of camera angle there, but that's about 1/2 right now. So what I'm going to do is I'll bring it back around the front and verify that it zeroes out again. So that's plus 1/10 there. I think I was plus on the other side as well. Yeah, I banged the indicator when I took it across there. I don't know if you heard that or not, but let's set it up again. So I've got that zeroed out there now again. I'm going to try not to bang it. So there's 1/10 across there right now. So I've run it all the way down to the other end, and I'm just slightly surprised that it's within 2/10 end to end and side to side. A slight problem is I don't have a good bearing surface yet. It's close. So I got to be really careful at this point that I don't change geometry now as I try and get the bearing quality I want. Like I said, surprised. I knew I was in decent shape. I just didn't know it was that good for geometry at this point. So I got to slow down here and make sure I get surface quality, and then we're off to the races. So I've been spending a considerable amount of time working away on the ways for the table here, and currently I've got the entire table up on the surface plate, and I've been surveying the ways, and then I've put the saddle, which is upside down here, but I've put it up on the table as well. And I just use a little flat surface here. This is a ground block, and I'm just using a height gauge, or not a height gauge, my tense indicator, and I'm zeroing here and just kind of surveying the four corners end to end. What does it look like? So on this side here, either in this position here or this position here, this end, the center, or the far end, I'm running about 2/10 difference across those 6 measurements. So 2 measurements here, 2 in the middle, 2 at the far end. On this side, that's about 2/10. I'm running about the same, 2 to 3/10 difference end to end when I'm measuring on this side here. The only difference is there's about 5 or 6/10 difference from this side to this side, which is you know, not a big deal. The only thing I'm trying to sort out right now is it's actually the opposite of what I see this surface to this surface, the actual ways on the table. So I need to work out, I'm actually going to get just the saddle back on the surface plate. Make sure, double check that before I start to change anything, because we're close, we're within a half a thou now, and I want to get even better than that. But I need to understand the relationship between the table and the saddle, and the geometry of the two of them together. So I used the depth mic, and I measured from this this surface here on the saddle down to this 1, 2, 3 block, just to help with the height here. And this 1, 2, 3 block is sitting obviously on the surface plate, and I'm actually seeing side to side, both sides of the saddle are really good, but I am seeing that 6 or 7 tenths difference across here as well. So this measurement with the depth mic is lining up with what I was seeing with the indicator, and just using a 0 point here. So next step is I'm going to double check the weigh surface side to side and end to end. I'm going to use a 1, 2, 3 block just to take up any kind of surface issues with the scraping, and then a small ground block down on the surface plate to do the same thing, and check the 4 corners here and see what's going on. So one of the other ways that I wanted to measure the table and the geometry with the saddle, as I've been doing it in the inverted position with the saddle on top. One of the things that I wanted to simulate was the weight of the table on the saddle weighs both the X and the Y direction. So with the saddle down, the table on top, I don't have a gib in it right now, but because I'm not measuring geometry in that orientation just yet. And I got a lot of hieroglyphics all over the table here. I've been measuring a few different ways. I've been using a depth mic down to a block. I've been miking my thickness here, just checking some things. But at this point, with a good sturdy base here and my tenth indicator, no, I just went and bumped it, but what's happening is at 18 inches, which is the width of the saddle, the 4 corners here, or the 4 points here that represent the 4 corners of the saddle, I'm 0, 0, 0, and I think down here I was plus 2 tenths down here. And the other thing I've done is, with the indicator on the bottom of the ways of the table, I'm 0 across the 4 corners. So the bottom line is, at this point, I'm going to call this very, very close. I really want to see it on the machine, and I really want to see it with a gib, so I'm not going to keep chasing until I understand in its working position what it's going to do, which requires, at this point on the ways here, just a few more cycles, because the bearing surface is getting good now, and then I got to turn my attention to the gib. So I think for now, the actual time to make this this recent video is extended. Stuff happens, you know, life gets in the way, and or life happens, and it's just been very little time spent on it. But at this point now, like I say, I'm going to turn my attention to the fixed dovetail and start to straighten it out and get that close, get the gib close, and then start to, like I did on the other pieces on the saddle, right, is get it on there, get it adjusted, and start using the lead screws to move things around to really see what the geometry is going to do as the part sits on the machine.